The science behind the northern and southern lights, known as the auroras, is a captivating natural phenomenon that lights up the polar skies with beautiful displays of colorful light. These dazzling light shows, also referred to as the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere, have fascinated humans for centuries. They are not only mesmerizing to look at, but they also represent a unique interaction between the Earth's magnetic field and particles from the sun, offering a window into the dynamic nature of our planet's atmosphere. The auroras are caused by solar winds, streams of charged particles that are emitted by the sun. These particles are primarily electrons and protons, and they travel toward the Earth at high speeds, often reaching the planet's atmosphere. When these charged particles come into contact with the Earth's magnetic field, they are channeled toward the poles. The Earth's magnetic field is strongest at the poles, which is why the auroras are typically seen in regions closer to the Arctic and Antarctic circles. As the solar wind particles collide with gases in the Earth's atmosphere, particularly oxygen and nitrogen, energy is released in the form of light. This light is what we observe as the aurora. The color of the aurora depends on the type of gas involved and the altitude at which the collision occurs. For instance, when oxygen molecules are excited at higher altitudes, above 150 kilometers, they produce a reddish-orange or greenish light. At lower altitudes, oxygen produces a more vivid greenish color. Nitrogen, on the other hand, can produce purples, blues, and pinks when it is excited by solar particles. The specific colors and shapes of the auroras depend on several factors, including the solar activity, the strength and frequency of solar wind, the composition of the atmosphere, and the strength of the Earth's magnetic field. When the sun is more active during solar storms or sunspots, the solar wind particles are more numerous and energetic, leading to more intense auroras that can be visible at lower latitudes. These solar storms are the result of disturbances on the sun's surface, such as solar flares or coronal mass ejections, so CMEs, which send large bursts of charged particles toward Earth. One of the most visually striking features of auroras is their dynamic movement. Auroras can appear as arcs, curtains, or even waves of light that ripple across the sky. This movement is caused by the Earth's magnetic field, which causes the charged particles to spiral along magnetic lines, creating patterns of light that shift and change in response to the varying intensity of solar winds. The auroras can also flicker or pulse in brightness, which is a result of fluctuations in the amount of solar energy reaching the Earth's atmosphere. The auroras can be seen most vividly in areas near the poles, such as Alaska, Canada, Norway, Sweden, Finland, and Iceland in the northern hemisphere, and in places like Antarctica, Australia, and the southern parts of New Zealand in the southern hemisphere. However, during periods of intense solar activity, the auroras can extend to lower latitudes, allowing people in places like the United States, Northern Europe, and even parts of Asia to witness this spectacular natural light show. The study of the auroras is not only fascinating for its beauty, but it also provides valuable information about space weather and the behavior of the Earth's magnetic field. Space weather refers to the interactions between the solar wind and the Earth's magnetosphere, and studying auroras helps scientists understand these interactions better. By observing the auroras, researchers can gain insight into the processes taking place in the upper atmosphere and how solar storms affect the Earth's ionosphere, which can have implications for satellite communication, GPS systems, and power grids on the planet. One important area of research involves understanding the impact of solar storms on Earth's technological infrastructure. Solar storms, which can cause geomagnetic storms, have the potential to disrupt satellite operations, communication systems, and even power transmission networks. These storms can induce electric currents in the Earth's magnetic field, which may lead to malfunctions or damage to sensitive electronics. While the auroras themselves are beautiful to watch, they are also a visible indicator of the solar activity that can cause these disruptions. In addition to their scientific value, auroras also have cultural significance for many indigenous peoples who have lived in the polar regions for thousands of years. In northern Scandinavia, for example, the Sami people have long held the aurora in reverence, incorporating it into their mythology and folklore. The auroras were often thought to be the spirits of ancestors or celestial beings, with different cultures interpreting the lights in various ways. For the Inuit, the lights were seen as the spirits of animals, while in some Norse traditions, the auroras were believed to be the reflections of the armor of Valkyries, the warrior maidens of Viking mythology. The spiritual and mystical significance of the auroras continues to be felt today, as many people from all over the world travel to the polar regions in hopes of witnessing this awe-inspiring natural phenomenon. The connection between the auroras and solar activity has also led to the development of space exploration technologies. Space missions, such as NASA's Magnetospheric Multiscale (MMS) mission, use the auroras as natural laboratories to study the Earth's magnetic field and how it interacts with solar wind. By analyzing the data collected from these missions, scientists can better understand space weather and its effects on Earth's environment, providing valuable insights into how to protect technology and infrastructure from solar radiation. In conclusion, the science behind the northern and southern lights is a remarkable combination of solar physics, atmospheric chemistry, and the Earth's magnetic properties. These breathtaking light shows are not just beautiful displays. They are manifestations of the dynamic relationship between our planet and the sun. The auroras provide a unique opportunity to study space weather, the Earth's magnetic field, and the behavior of charged particles in the atmosphere. As we continue to explore the mysteries of the auroras, we gain not only a deeper appreciation of this awe-inspiring phenomenon, but also important insights into the natural forces that shape our planet.